Hey class, welcome back to week 4 of remote learning here. As you probably heard, right, we will no longer be going back to school this school year, right? Governor Pritzker called it that all schools from Illinois will not be going back. So that means we will not be back in the building, which is kind of unfortunate. And we'll be doing this remote learning from here on out for the rest of the school year this year, okay? We will hope to have some more Google Hangouts to do some review sessions and the meet and talk and stuff, for the remainder of the year, okay? So we are continuing with our polynomial unit here, but actually this week and the next couple of weeks, we're gonna be looking more into the factoring piece of this. So polynomials and factoring, they kind of go hand in hand. And this week and next week, we're going to be doing more factoring sort of things here, okay? Which is like a essential skill in algebra here, all right? So to prepare for this week's notes, all right, again, right, we're going to find all your materials and everything that you need in this e-learning folder, right? So if you open up their e-learning materials folder, right, we are going to be on week 4 here, okay? And in week 4 here, you're going to find this document called the factors chart, all right? So I want you to go ahead and open this document up. And if you're able to, right, I would print this document out. This will be a nice document to have. And you're going to need this document actually for the next like 3 weeks of e-learning here. All right. So go ahead and print this out, right? Download it. Or if you don't have access to a printer, right, just make sure you bookmark this or have this document up every time we do notes this week and next week. You're going to want to reference this factors chart document, all right? In my Edpuzzle videos, you'll hear me reference it a lot. All right. So speaking of the videos and the notes, right? Well, it's time to take some notes here. All right. So we're on let me get my screen here. Sorry about that. All right, so this is going to be 7.4, day 1, factoring polynomials using a GCF, all right? So just like the previous 3 weeks here, right, print out these notes if you can, so you can follow along with the video. If not, that's okay. I'll kind of tell you when to write things down here as we're going along here, okay? So here we go. So factoring, right? We had a couple of vocab terms here for factoring using a GCF, right? So we got factors, right? Factors are just numbers or letters you multiply to get another number or expression, right? So factors are the things that get multiplied. All right. And then we have the greatest common factor is going to be the greatest factor that evenly divides into each term. All right. Remember, term is a number, a letter, or a combination of numbers and letters. All right. So we have factors are things that multiply to it. And the greatest common factor is going to be the greatest factor or greatest number or greatest polynomial or monomial that goes into each of the terms. Okay. So to find the GCF, all right, to find the GCF of a set of monomials, there's kind of 2 things you have to do. All right, the first thing is to write down all the factors of each monomial, right? And you want to write these in order. I'll kind of make it a little bit easier to find your GCF, okay? And you're asking yourself, how do I find those factors? Well, you're going to use that factors chart, all right? You want to use this factors chart to help you find all the factors, all right? Now, sometimes you may know some of the factors, which is great, but if we don't know all the factors, then you want to definitely reference this factors chart to help you find the factors, all right? And once we list out all factors, right, we're going to circle the greatest factor that each monomial has in common. All right, so you kind of see a little more what I'm talking about as we do these examples, all right? So now this is here where you want to write this example down and write what I write if you do not have a printed version of these notes, okay? So here we go. So we're asked to, in example 1 here, find the greatest common factor, or GCF, of 12 and 28. All right, so as you can see here, we got our 2 factors, 2 numbers, 12 and 28. All right, and there are some lines here, right? This is going to tell me how many factors there are. Okay, so for the number 12, there are going to be 1, 2, 3, 4, 5, 6 different factors. All right, and to find what those factors are, right, we can look on this chart here. Right, you can see the number 12. It's 1 and 12, 2 and 6, and 3 and 4. Right, those are the 6 factors of 12. All right, but I want to go ahead and list these out in order, okay? So 1 and 12, we have 2 and 6, and we have 3 and 4. All right, and for the number 28, we also have 6 factors. All right, again, if you know the factors already, you can fill them on these lines, right? If you don't know what the factors of 28 are, right, that's where you want to use this chart here to kind of find the factors of 28, right? And they're right down here, 1 and 28, 2 and 14, and 4 and 7. All right, again, we want to put these in order though. So 1 times 28 gives me 28, right? 2 times 14 gives me 28, and 4 times 7 gives me 28, right? That's are the factors of 28, right? The numbers that multiply to get you back. All right, so after we list all these out, right, we're going to scan both of these rows and find the greatest one in common, or the biggest number that's in common between 12 and 28, right? And we can see that 1's in common, 2's in common, and this 4 is in common, right? And 4 is the greatest one in common, so 4 is going to be my GCF. All right, that's not too bad, right? Just listing some numbers out, all right? So why don't we try 18 and 54, all right? So again, we have to list out the factors of 18, list out the factors of 54, and see what is the greatest in common that they have. So we have 1 times 18, we have 2 times 9, and we have 3 times 6, right? Those are the 6 factors of 18. All right, ooh, 54. I don't know if I know all my factors of 54, so I'm just going to take a quick look at my factors chart here, right? So 54 is right there. So it's 154, 2 and 27, 3 and 18, and 6 and 9. All right, so we said 1 and 54, 2 and 27, 3 and 18, and 6 and 9. All right, I listed out all my factors. Now I'm going to find the greatest in common between these two numbers, right? It looks like 18 and 18. All right, and like I said, if we list these out in order, it's going to make finding that GCF that much easier. Okay, awesome. Let's go on. All right. What if we have to find the GCF of 3 numbers? Well, guess what? It's going to be the same idea, right? We're going to list out all the factors of each one of these 3 different numbers, and we have to find the greatest thing in common for all 3 of them. So we have 1 times 6, and we have 2 times 3, right? Those are my only factors of 6. And for the number 15, we have 1 times 15, and we have 3 times 5. And then for the number 21, right, we just have 1 times 21, and then 3 times 7. All right, so now to find the GCF of these 3 sets of numbers, right, again, I'm just looking for the greatest thing in common, right? Well, they all have 1 in common. They also have 3 in common. So 3 is going to be my GCF. All right, and for something to be a GCF, it needs to be the greatest common factor in all 3 terms, or all 2 terms, or depending on how many terms you have. All right, now we're going to step it up a little bit. All right, now we're going to throw some variables in here, okay? Because we're going to be asked sometimes to find the greatest common factor of a monomial, right? And sometimes our monomials have these variables in them. All right, so now example D here, we have 4x squared and 10x. All right, so as you can see, right, we're going to have to find the GCF of my numbers, and we're going to have to find my GCF of the variables if there is any of them. All right, so for 4x squared, all right, you can see how many spaces I have. That's how many factors I'm going to have for 4x squared, all right? I'm going to have to put some sort of number or value in each one of these lines here, all right? And my suggestion for when we have these problems with variables in it, all right, is to always start with your variables first and put them on the end here, all right? So x to the second means I have 2 x's, right? Because x times x is x to the second power, all right? If I had x to the third, I would have 3 x's, okay? So for 4x to the second, I'm going to have my 2 x's. I'm going to put those at the end, and then my factors of 4 are 1 times 4 and 2 times 2. All right, and my factors of 10x, all right, are going to be, well, I have that 1x, so I got to put the 1x here, right? Again, I want to put those x's at the end to kind of keep them organized, all right? So now for factors of 10, it's going to be 1 times 10 and 2 times 5. All right, so now it's time to find the GCF of these two values, all right? And to do that, again, look for your numbers first, all right? Let's see, oh, I got a 2 and I got a 2, right? That is the greatest number in common. All right, and in this case, it looks like both of these terms, they both have an x in common, all right? So that is going to go up here as part of my GCF as well. All right, they only have one x in common, so that's why it's just x here, and the number 2 is in common, so 2 goes there. So my GCF of 4x squared and 10x is 2x. All right, let's try another one here. All right, and actually this is the last one, and then you guys are going to have some practice work to do on your own here to see how you do with this stuff, okay? So here we go. We have 3x to the third and 7x squared, all right? I'm asked to find the GCF of those two terms, or those two monomials, all right? So again, 3x to the third means I have 3 x's, and I'm going to put those 3 x's down first, and I'm going to put those all the way to the right. All right, so x is x to the third. All right, and then my factors of 3 is just 1 times 3. And then for 7x squared, right, it's just going to be x and x, because x times x is x squared. And then my factors of 7 is just 1 times 7. All right, and now again, I'm going to look for my GCF of my numbers. Well, the only number I have in common is 1, and that's okay sometimes, right? Sometimes that's going to be my only number in common is going to be that number 1. All right, and now to find my GCF of my variables, right? How many variables do they have in common, right? Or what are my common variables? Well, let's see. I have one x in common. Oh, I have a second x in common, right? And if we have 2 x's in common, it's going to be x to the second power. All right, and if there's 3 x's in common, it'll be x to the third power. If there's 4 x's in common, it'll be x to the fourth power. Okay, but they have 2 x's in common in this problem, so that's why it's x to the second power. All right, this term has an extra x, but that's okay because this one does not, so it can't be a greatest common factor, and that's okay. All right, so my GCF of 3x to the third and 7x squared is 1x to the second, right? Or simply, I can just write x to the second power, right? I don't have to have that one there, but I can if I want to. All right, so hopefully that makes a little sense, right? And hopefully you watch the other video too, had the other guy explain these GCFs as well. All right, and now I think you're ready to start on that homework.